Hello and good morning to everyone. So our today's lead code question is 3379, that is transformed array. So in this question we are given an integer array nums, that is basically a circular array. So what is a circular array? So suppose if we are given an array, so a circular array is such that after last element we will be come to the first element in this direction, right? Or else if you have to rotate like this also, so after first element we will go to the last element. So this is basically a circular array. And so what is our task is to create a new array result of the same size. And what are the rules for that? So if nums of I is greater than 0, means any element is greater than 0, then what we have to do is we have to start from that particular index and move uh, the nums of steps to the right of the circular array. So, and if nums of I is less than 0, then we have to move from index I to index I to the left. To the left, how many steps? Nums of I steps, right? And if it is equal to 0, means we won't be moving any step. So result of I is equal to nums of I. So we have to return the uh, new array result of I. So if you'll see with an example, so here it is given 3, so we have to move 3 steps ahead. 1 2 3. So result for 3 is 1. Now it is given -2. In case of negative elements, we need to move to the left. So one step and then two steps. So for this also the answer is 1. Now here it is given 1, so one step ahead. So for answer for this also 1. Now here last element is 1, so we have to move one step ahead like this circular array. So we'll go to 3. So the our answer is 1 comma 1 comma 1 comma 3. Now let's see the next question, next example, sorry. So here it is given -1, so we have to move one step to the left, that is we will go from here to here. So now here it is given 4, so we have to move 4 steps ahead. 1 2 3 4. So for first element it was -1, for second element again it was -1, and in this case we have to move one step to the left, so 4. -1 -1 4. And if you'll see the constraints, the nums dot length is up to 100, and all the elements can be from -100 to 100. So let's see the two different approaches that we will be following. So first one is like using mode operations. So what we'll do is, see, if nums of I is greater than equal to 0, in that case we have to move nums of I step ahead from the current index, that is current index is suppose I, so we have to move to the right. How, by how many steps? By nums of I step. And suppose if our array is present up to here, so what it then if we'll keep going ahead, it will go out of bound, it will give out of bound error. So what we will do, we will be, so our new index will be I plus nums of I, and then we'll do modulo operator. So suppose here, so we have to go 5 step ahead. 1 2 3 4 5. What is the index of this element? 0 1 2 3 4. Index is 4. 4 plus 5 is 9. If we'll do 9 modulo 7, so we'll get 2, right? This is modulo operator, right? And if you'll see in the normal array, 1 2 and then circular array, 3 4 and 5. See, we landed at index 2. So, and by 9 modulo operator 7 also, it was given 2. So, new index will be I plus nums of I modulo n, and then result of I is equal to nums of new index, right? What if the other case is, what if nums of I is less than 0? So, in that case, what we'll be doing is, first we'll be taking the absolute value of nums of I. So suppose it is, if nums of I is minus 5, the absolute value will be 5. And see, a is equal to absolute. So absolute is a function that is used to find the absolute value. So what are the two possibilities for this a, that is absolute value of nums of I? So it may be possible that a may be greater than n, right? So let's see here. Here, see, 9 was there, right? So if we have to do 9 operations, then that means we keep one loop through the array and then go to 2 steps, right? 7 plus 2. So if any element is greater than the size of the array, then what we can do, we can directly avoid the loops that we have to do. And for that, what we can do is we can modulate it, like a modulo 9. So 9 modulo 7, we if we have done, then we know that we have to do only two movements, right? And then what we'll do is we'll check whether a is less than equal to current index or not. If it is less than or equal to current index, then that means our answer is from 0 to I, because in case of negative elements we have to go to the left, right? And now we are at current index I, where value is, absolute value is a, and this a is less than this index, means we have to take a steps. So suppose we have to take only two steps. We are currently at index 3 and we have to take two steps. So what will be our new index? Our new index will be I minus a. What other case can be there? If a is greater than I, this a is greater than current index, then that means we have to take more steps. So first we will take I steps. So if we'll take I steps, that is, I steps will reach to 0. So how many more steps are left? That is a minus I. So those a minus steps will be taking from this last point, right? So we'll be subtracting that from n minus a minus I, that will be our new index. So our result of I is equal to result of nums of this new index, right? Then let's see the code part. So it is given that first we have taken the size of the array, then result. So if nums of I is greater than equal to 0, then our new index will be I plus nums of I and modulo n. Modulo n we are using to avoid the loop, right? So suppose if our array is of 5 elements and then I plus nums of I is 7. So instead of doing 1 2 then 3 4 5 6 7 steps like this, see, this part is common, so we can avoid this loop, right? And so this modulo helps us in avoiding the loop situation. And if nums of I is less than 0, we will be taking its absolute value and then doing modulo, because a can be greater than the size of the array. So again modulo is required, and then check if a is less than equal to current index, then our answer will be I minus a. Else what we'll do is, else we will be subtracting a minus I, this a, it will be minus, because I have simplified minus minus plus. So we'll be taking this element and at the end we will be returning the result. What other approach we can follow is, we'll be storing the array three times. So suppose our array initially is a b c d. So what we'll do is we'll store it three times, right? And then iterate over the middle array. Then we don't have to jump from here to the last, because see, if we have to go from A to E, then earlier we have to jump to the last, but now see, the previous element is E only. So we can you be using this approach also. So let's go directly to the code part. So first of all, we have taken the size, then a new vector to store the array three times. Then we have stored the array three times, and then we'll be iterating in the middle part of the array from n to 2n. So if we are checking whether our element is greater than equal to 0, right, then we'll be taking modulo and then directly I plus a, right? here nums of I minus, and we are storing the result in nums of I only, right? And if it is less than 0, then we are taking it again, finding the absolute value, doing modulo, and subtracting from the correct index, right? And at the end we will be returning the result. I hope you are able to get both the approaches. So if you get the solution, please make sure to like, share and subscribe. Thank you.